Hi, I'm Rich with insideHPC. We're here with the HPC User Forum, a series of conversations with the steering committee. Today, my guest is Doug Ball. Doug, welcome to the show today.
Thank you. Glad to be here.
Well, Doug, I know you've been retired not for now 6 years, right? Can you tell me how you got started in HPC?
Yeah, that's kind of an easy one. When I left General Dynamics and went to Boeing in early 1977, my first job was actually developing a CFD tool, a 2D code to be able to analyze the flows over multi-element airfoils. Okay, in airplane terms, that's the flaps for takeoff and landing. And it was modeling it with separated flows, which had never been done before. And I've had one class in computer programming. I'd never done anything in CFD before. So it was trial by fire.
Well, great. So can you tell us about your HPC background? What happened after that?
Yeah. So like I said, I really didn't have any formal training, but I was hired into aero research at Boeing. And fortunately, there were two classes of people that were all very friendly and very willing to serve as mentors. I had good computer scientists and great mathematicians. And so whenever I came up against something I didn't understand, all I had to do was turn around and ask somebody, and I had all the help I could get. So that's pretty much how I got into it. I have I've either used CFD when I was an engineer, or I've managed CFD developers, or I've managed the users of CFD practically throughout my entire career. You know, it was at a time when airplane development costs were becoming an issue. And so people were looking at how can we reduce the amount of wind tunnel testing. And so, it was either a case of being at the right place at the right time or the wrong place at the wrong time. I haven't figured that one out yet.
Okay. So, Doug, you must have seen a lot of changes in HPC over the years. What were the biggest changes?
Yeah, this was the fun question to contemplate because it took up probably 90% of the time that I spent, putting my answers together. So when I started, Seymour Cray was just starting to come on the scene. So that 2D code that I talked about, we were cramming that into a CDC 6600. That's where I learned about overlays and also learned about how little memory there was available to do anything. And of course, the 6600, while it was a good machine, it clearly wasn't as fast as the first Cray machine that came on. And of course, Cray had a distinct advantage over everybody else in that it handled, for a user, the matrix arithmetic was as easy as the scalar arithmetic. They had all the libraries and everything. And so you could say A times B, and A was a huge matrix and B was a huge matrix, and hey, C had the answer. Fabulous from a user standpoint. But we still had the issue of memory. Okay, so the speed went up, and I should probably back up and say that at Boeing, as HPC capability increased, we always kept expanding the size of the problem, the magnitude of the problem, the level of fidelity of the problem to fill up whatever capability came along. The next big improvement I would have to say that we experienced was the advent of SSD, solid state disk. Because before that, doing reads and writes, like with overlays and that kind of thing, writing to magnetic media is not the fastest process in the world. So having solid state disk was a huge boon to job run times, clock times. And that's what the users care about. They don't care how much CPU time it takes. The only thing they care about is if I put my job in at 4 o'clock this evening, will it be available for me at 7 o'clock tomorrow morning? So that was, the next big step. And of course, the Cray improvements came along. And for the longest time, we rode the coattails of NASA Ames. We actually modeled our first couple of data centers directly after the Ames facility, the NAS. So it was great because we had a chance we could prototype our software, get everything up and running, then we would have our hardware get delivered, and literally by the time when Cray said it's ready to go, so were we, because the software we knew already ran because we'd been running it in Mountain View. Obviously, then I think the next step was the advent of parallelization, and parallelization came along at a time when it wasn't obvious that Moore's law was going to keep working anymore for a single chip. But it also helped address the memory issue, because now you could hang memory off of, 50 processors, then 500 processors, then 5,000 processors. And of course, the challenges there were, how do you make these guys, the conductor has a bigger and bigger orchestra that he has to keep in sync. But it helped address the memory issue. So we could run larger and larger jobs, and obviously, the more processors you have, it reduces the cycle time in terms of getting those jobs. So that, to me, that's kind of where I've seen, the speed thing come along, the big improvements. On top of all of this, when you're an industrial user, the overarching thing is cost. And so you're always looking at, how much is this going to cost me? We're going to get benefits? And believe it or not, we had one Cray purchase that we weren't going to do because we couldn't make the cost benefit analysis work, until one of my really good engineers, John Busoletti, went, wait a minute, have we looked at the cooling costs? And when we looked at the whole data center, if we put this new processor in there and take the old one out, the air conditioning requirements dropped dramatically, and then it became a no-brainer to buy the new machine. So, overarching cost was always sitting there as a forcing function. And of course, sometimes you could justify spending more on computing as long as you were confident that you would do less physical testing. And Boeing's been pretty successful with that. So,
well, great. So you still follow the industry. I see you at all the meetings. So where do you think HPC is headed?
Wow. That's a really good question. Because I'm a user as opposed to somebody who's heavily involved on kind of the hardware side, I may not be the best person to answer that. But since you asked, I honestly think when you back up and you look at, so what drove HPC to begin with? CFD and oil and gas, those people were really big drivers early on. Then we kind of became, I'm going to call it 2-bit players, and the gaming industry is what started really driving what was going on, as well as people like PayPal and Google, people that are, for them, HPC is not, it's not one job needing 1 million processors. It's like 1 million jobs that all have to be done in the wink of an eye, and they each get their own processor. And I'm not going to argue whether those are both HPC or not. That's kind of a moot point. But I kind of looked at that and went, okay, so those were like totally unrelated events. And I'm going to speculate that autonomous mobility may be the driver for where HPC goes in the future, in terms of, and I'm leaving it open to whether it's cars, boats, airplanes, helicopters, UAVs. All of these things are going to have to be able to analyze their situation, predict what outcomes are possible, and then they have to decide and act. And they won't necessarily be able to do that just by themselves. So I think we're liable to see a drive towards how can we drive the package size of HPC down so that we can put it in all of these devices that are going to need it in the future, because they're all going to have an overriding risk that a lot of these other, and it's the risk to human life. Gamers and CFDers and stuff, no, because we're going to go off and do other things. And obviously gaming doesn't risk anybody's life. But when I'm talking about two cars approaching an intersection, they have to know exactly what each other's going to do. So that's my 2 cents worth.
Okay, Doug. Well, are any HPC trends got you particularly excited or concerned?
Well, yeah, I'm excited from the standpoint of, the previous question. I admitted that I wasn't maybe the best person to ask. I said, but you know what? That's what makes it exciting, is because you don't really know what it is. And it's that part of the journey that's going to be exciting, is something's liable to pop up that nobody ever thought about. One of the things that rarely gets a lot of talk about, but a friend of mine who worked at NASA, her husband was a dentist. And he had some health issues, and so he could no longer really practice dentistry. So he started in and he took CFD and he took the modeling and the visualization, and he started processing x-rays and that kind of stuff and figuring out how to use the HPC software and applied it to the dental industry. And that was 35 years ago. But, we rarely or if ever talk about that kind of thing.
Sure.
So, it's autonomous mobility is obviously coming. So I don't think it's that big a stretch is to say that that's going to be a driver. As to whether it's going to be the 500-pound gorilla in the room, who knows?
Yeah.
But again, and the thing about that one is to me, there's also the big risk question. So.
Well, great, Doug. Anything else you want to bring up here that we didn't touch on yet today?
No, other than, boy, when you look back 45 years ago at what we could do then versus what we can do now, it's really quite amazing. The one disappointment that I do have, though, is that there's still an awful lot in the area. I realize HPC is more than CFD. Okay, I get that. But in the area of CFD, where we have really plateaued because of the physical models, and we're going to have to wait for some other quantum leap before we can bring in direct numeric simulation and that kind of thing, where the models are enormous compared to even today's really big ones, which are enormous compared to what they were 20 years before. And as to whether qubits are going to play a role in the future, I don't know enough about that one to speculate, but there's certainly a lot of people spending a lot of effort on it.
Oh, you got it.
Yeah.
Well, hey, Doug, really appreciate you coming on, and stay safe down there in Arizona and on the golf course.
Absolutely, and hopefully I'll see you at the next forum.